All right, well, hello there, seventh graders. Yesterday in lesson 1.2, we kind of started talking about adding negative and positive numbers, and that's going to kind of be continuing today. But the focus is going to be on rational numbers. So we're going to be involved with fractions and decimals and those sorts of things. But it's going to be those same principles that we did yesterday when we were doing whole numbers. So, for example, we're going to start here. Find the sum. Negative 1/2 plus a negative 3 over 2. Now, remember, once again, they put the commas, or not the commas, the parentheses to separate the operational signs. They don't want two operational signs together. So the fact that they're both negative means that I can just do 1 over 2 plus 3 over 2. Now I know that 1 over 2 plus 3 over 2 is going to equal 4 over 2. But they're both negative, so it has to be a negative 4 over 2. Now, when it's fractions and all that, we got to simplify. I know that a fraction is just a division problem. 4 divided by 2. 4 divided by 2 is 2. So that tells me that the answer that I'm looking for is negative 2. Moving right along, 1 3/8 plus 3/4. 1 3/8 plus 3/4. Now, what we want to realize is that we know that 1 3/8 is bigger than 3/4. Forgetting about the negative for a second. We know it's negative, but if we were just not to worry about the negative, we would know that 1 3/8 is bigger than 3/4. So that means that since I'm moving right on the number line and I'm adding a positive number, I'm getting closer to 0, my digits are actually getting smaller. Because if we think about a number line, if we'd have -7, then -6, -5, and so forth until I got eventually to 0. Okay? So it's the same idea. If I'm at -1 3/8, I'm moving to the right 3/4. I'm not getting to 0. It's still going to be a negative answer, but my digits get smaller, just like they do here. 7, 6, 5, the closer they get to 0. So that tells me that I can just do 1 3/8 minus 3/4. And I just have to remember that the answer is going to be negative. Well, I'm seeing 8 and 4, so I'm thinking a common denominator. I'm thinking we're going to keep 1 3/8 the same. It's going to become something over 8. 4 times 2 is 8. So I'm going to think 3 times 2 and get 6. Well, I can't do 3/8 minus 6/8. So I'm going to borrow from the 1 and make it a 0. And so I'm going to add 8/8, which is my 1 whole part, to the 3/8. 3/8 plus 8/8 is 11/8. So it's 11/8 minus 6/8, which is 5/8, but it has to be a negative 5/8. All right, moving right along. 4 plus a negative 7 over 2. Well, when I add a negative, remember I'm just subtracting. So it's basically 4 minus 7 over 2. Now, if I think about 7 over 2, 2 can go into 7 3 times. There'll be 1 left over. So that tells me that this 7 over 2 is the same as 4 minus 2 can go into 7 3 times. There's 1 left over. So my denominator will be 2. So it's 4 minus 3.5. So if I come up here and I'm going to do 4 minus 3.5, well, I have to borrow from the 4, make it a 3. I borrowed 1 whole part, so that's going to be 2 over 2. 2 over 2 minus 1 over 2 is 1 over 2. 3 minus 3 is nothing. My final answer is 1/2. So it's the same idea as what we were working with whole numbers. We're just now having to remember fractions, common denominators, all those things. Let's go ahead and fix that. All right, now this idea with fractions. Well, here we have -3 3/10 plus a -2 7/10. Once again, the negative sign. So we're separated by the parentheses. They're both negatives. So that tells me that really I can just do 3 and 3/10 plus 2 and 7/10. And I just have to remember that there's a negative, that it's a negative answer. 3 plus 7 is 10. Put the 0 down, drop the decimal, carry the 1 from the 10 since 3 plus 7 was 10. 1 plus 3 is 4. 4 plus 2 is 6. 6.0 or just 6, but it's a negative since both of these are negative. Negative 6.0. Negative 5.35 plus 4. So once again, it's the same idea. I know that without the negative, 5 and 35 hundredths is bigger than 4, but it's a negative. I'm moving right on the number line, so I'm getting close to 0, so closer to 0. So my numbers, my actual digits are getting smaller, which means that really what I'm doing here is 5 and 35 hundredths minus 4. Remember that 4 is in the ones place. If I want to, I can add 0.00. 5 minus 0 is 5. 3 minus 0, drop the 3. Drop the decimal. 5 minus 4 is 1. But remember, since this is a bigger number, I'm not going all the way to 0. So that tells me that this has to be a negative 1 and 35 hundredths. All right, last one in this first section. 1 and 65 hundredths plus a negative 9/10. Now remember, when I add a negative, it's just like I'm subtracting. So it's really 1 and 65 hundredths minus 9/10. So if I come over here, 1 and 65 hundredths minus 9/10. I can put a 0 there if I want to. 5 minus 0 is 5. I can't do 6 minus 9. So I'm going to borrow from the 1, make that a 0, make the 6 a 16. 16 minus 9 is 7. Drop the decimal down. If I want to put the 0 there, I can. I get 0 and 75 hundredths. All right, moving right along to our next part here. Now we're going to start to have 3 numbers in the problem. So sometimes when we get 3 numbers in the problem, it's kind of good to think, well, what can we do? What actually makes sense? What can be combined? So I'm looking at this first one, 3 and 7/10 plus a negative 5 and 36 hundredths plus a negative 3 and 7/10. Well, I'm seeing that both of these are negative. So what I'm going to go ahead and do is I'm going to just take 5 and 36 hundredths. I'm going to add 3 and 7/10. Remember, decimals always need to be lined up, 7th graders. Drop the 6. I can put a 0 there if I want, but it's not necessary. 3 plus 7 is 10. Put the 0 down. Carry the 1. Drop the decimal. 1 plus 5 is 6, plus 3 is 9. I get 9 and 6 hundredths. But since they're both negatives, it's actually a negative 9 and 6 hundredths. So now that leaves me with 3 and 7/10 plus a negative 9 and 6 hundredths. Now remember, when I'm adding a negative, it's just like I'm subtracting. So it's like 3 and 7/10 minus 9 and 6 hundredths. And I can think of this as 9 and 6 hundredths minus 3 and 7/10. But I just have to put a negative answer in front of it. So I'm going to come over here. 9 and 6 hundredths minus 3 and 7/10. Drop the 6. Can't do 0 minus 7. Borrow from the 9. Make that an 8. Make that 0 a 10. 10 minus 7 is 3. Drop the decimal. 8 minus 3 is 5. But since my original problem was the 3 and 7/10 minus the 9 and 6 hundredths, I know that this answer needs to be negative. Negative 5 and 36 hundredths. All right, let's go to the next one. 1/5 plus 4/5 plus 5/7 in parentheses. Now, the order of operations, PEMDAS, parentheses, then exponents, multiply and divide left to right, add and subtract left to right. We don't want to forget that mentality, but what we do need to remember is that even though these parentheses are here, the fact that everything is an addition sign, those parentheses really don't mean anything. Because everything's addition, I don't have to do those two things first. So this is a perfect example of something that we want to look at. And we see two numbers that are can very easily be added together. Same denominator. 1/5 plus 4/5 is 5/5, and I know that 5/5 equals 1. So this part right here, I know equals 1. And well, then if I add to the 1, this 5/7, 1 plus 5/7, I know that that just equals 1 and 5/7. And there you go. All right, moving right along. 7 plus 2 2/3 plus a negative 3 5/10. Well, 7 and 2 2/3. If I were just to come over here with the 7, and I'm just going to go ahead and add 7 to that. 2/3 plus nothing is 2/3. 2 plus 7 is 9. I see that those two added together equal 9 2/3. Well, now we're plus a negative 3 5/10, which means we're subtracting 3 5/10. Now I can take that 3 5/10 and make it a fraction. Now, I also can see that 3 5/10 is not in simplest form. 5/10, if I divide them both by 5, 5 divided by 5 would be 1. 10 divided by 5 would be 2. I would actually end up with 3 1/2. So I can actually come over here and do 9 2/3 minus 3 1/2. And it's always good because with 10 and 3, I would have ended up with a common denominator of 30. And you always try to make it as easy as you can. It's going to be much easier with 1/2 because I can see the 9 2/3 minus 3 1/2. And I can see that my common denominator is 6. Well, 3 times 2 is 6. 2 times 2 is 4. 2 times 3 is 6. 1 times 3 is 3. Well, when I go to subtract, 4/6 minus 3/6 equals 1/6. 9 minus 3 is 6. I end up with 6 and 1/6. And 1/6 is in simplest form because the only number that can go into both 1 and 6 is 1. All right, last one, 7th graders. Negative 5 2/10 plus 3/5 plus 14. Well, first let's kind of do what can be combined, which would be this negative 5 2/10 plus 14. Well, as I know, addition problems can always be flip-flopped, okay? So this can actually become 14 plus a negative 5 2/10. Once again, separating the operational signs with a parentheses. Whenever I add a negative, I'm just subtracting, so this is really 14 minus 5 2/10. Keeping the decimals lined up, I can make that 0.0, make it a little easier. Can't do 0 minus 2, so I borrow from the 4, I make it a 3, I make the 0 a 10. 10 minus 2 is 8. Drop the decimal straight down. Can't do 3 minus 5, so I borrow from the 1, I make it a 0, I make the 3 a 13. I do 13 minus 5, 13 minus 5 is 8. I end up with 8 and 8/10 there in that situation. Okay, but now I have the 8 and 8/10, and I need to add that to the 3/5. All right, so if I'm thinking 8 and 8/10, if I'm thinking, well, okay, let me think about 8 and 8/10. That to me does not look like it's in simplest form because 8 and 10 are both even numbers. Now we know when we simplify a mixed number, the whole number stays the same. But if I do 8 divided by 2, I get 4. If I do 10 divided by 2, I get 5. So I get 8 and 4/5. And I like that because that 5 is the same denominator as I have there. So I'm really going to end up doing, let's find where we have some room, 8 and 4/5 plus 3/5. All right, well, 4/5 plus 3/5 is 7/5. 8 and nothing is 8. Well, let's think about 7/5. If I come over here with 7/5, 5 can go into 7 one time. If I take 5 into 7 one time, there will be 2 left over. Because remember what I'm doing is I'm just taking 7 and dividing it by 5, which would be 1 remainder of 2. The denominator is 5. The 7/5 becomes the 1 and 2/5. But I can't forget about my 8. That 8 has to be included. So I'm adding the 8 to the 1, which in turn, I'm just going to cheat a little bit here, makes this a 9 and 2/5. Final answer. All right. We will talk to you later, 7th grade. Bye.